DNS and DHCP are two, for lack of a better term, kind of vanity services. You don't really need these on your network, specifically, but they're really nice to have. DNS lets you resolve IP addresses to host names, and host names to IP addresses. When you're running it on a local network, you can have a lot of machines with funky host names, and no one will ever know. You can have a lot of machines with funny host names, and no one will ever know either. By using DNS, you can have it set up so that instead of having to remember the IP addresses for the boss's notebook, or for the wife's computer, or even for your TiVo or whatever, they become names. And with DHCP set up correctly, you can have those names registered automatically. A lot of people do this already, kind of on their home router, their Netgear, or maybe their Cisco. Why should you do it on the server? You gain a lot, actually. One of the things that you can do is control your own DNS. You can set up a lot of kind of interesting side effects things. One of these side effects is that you get to run your own domain name, and you can make it whatever you feel like because it's not on the public internet. The second side effect is that it's going to teach you how to run DNS for the public internet. At some point in your career, you're going to do that, and it will be sooner rather than later. A couple warnings or just points of information before we start. First of all, I really wanted to pick something neat as my demonstration domain name for this, but I couldn't come up with anything that I thought the copyright had expired on or wasn't already well regarded and well taken. For instance, characters from The Hobbit or Transformers. Didn't want to do that, so instead I picked a more boring planets.lan. When you're setting this up on your own, you can pick any domain name that you want, including ones that have already been taken. But bear in mind that not only will they not work on the internet, they'll block anyone trying to use your DNS server internally from hitting the real website. So if you were to, say, pick your local demonstration LAN name as apple.com, any servers that were using your DNS server, meaning anything in your office or your house, are not going to be able to reach apple.com. And the final warning, caveat, whatever, is there's been a trend in using .local domain names for LAN setups. Really try to avoid this if you can. It breaks a lot of things. There's a service called Bonjour, or in Linux they'll be called Avahi or ZeroConf. It's got a lot of different names. But the main thing is that for .local domains, it will attempt to broadcast find host names before it checks DNS in a lot of configurations. And what will happen is you'll have your DNS all set up and everything will be configured correctly, but it just won't work. And you won't know why. And DNS queries are going to time out, and you won't be able to ping hosts. There'll be lots and lots of stuff wrong with it. So I have been just out of habit using .lan. You could use .fake, .l, .anything that you want. Just try to avoid using .local. And now that I'm done lecturing, we can go ahead and continue. The first thing that we need to do is set up a static IP address for the new server. Since we're going to be relying on it for actual services really for the first time, it needs to have a static IP address. We're going to be replacing the DHCP server that's on the router with the one on the server. So we can't rely on the router to provide the IP address for the server anymore, which it has been doing up until this point. We touched on this in the first part on networking, but we need to go back in and really set things up correctly. So we'll take a look at our current IP address, which is DHCP assigned from my local router, and we need to fix that. Debian derivatives store their networking information in a file called etc network interfaces. It's just plain text, and really it's pretty much the barest definition of what you need to do to configure an interface. First thing, go down and remove the DHCP part. And then we're going to go through and just configure a basic static interface. I'm assigning myself 235 here because I know it's outside of the DHCP range of the router that I have configured. You'll definitely want to check out your router configuration to make sure that you're picking something valid. We're just kind of laying the groundwork here to turn up DHCP in a little bit. We're going to do DNS first, but this way we have the IP address already configured and everything set to go. Etc initd networking restart rereads the configuration file, reconfigures the network for how we have it set. Based on this, I want to ping my router to make sure that I can still hit it. As long as I can, we can go ahead and move on to installing the DNS server. Just like Apache serves out web pages, a program called bind serves out DNS queries. Using apt-get, we'll go ahead and install bind using the bind9 package, and then we'll check out an initial run through the configuration directory. After that, we'll set up a basic DNS area called a zone for my planets.lan setup. All of the basic configuration files are stored in etc. bind. You can see here the basic listing of them. The two that we mostly want to concentrate on are names.conf and named.conf.local. Taking a quick peek at one of the files we can use as an example, db.local has kind of the general format of every bind configuration file that you're going to want to follow. This probably looks pretty foreign to anybody who's never set up DNS before, but it's again fairly straightforward, and we'll go through it line by line when we actually set up our first zone in a few minutes. Much like Apache, a couple of years ago, bind split out a lot of their configuration into multiple files, or sometimes multiple directories. And so normally where you would see an example zone in named.conf.local, there's a whole lot of nothing. So just taking a quick peek here, we can see that there's a named.conf.default zones, which probably has a configuration that we can steal pretty easily. And actually it does. So the first one up there, where we see zone localhost and zone 127, represents the two types of zone records you can have. The first is for a regular domain name, and the second is for something called reverse resolution, which maps IP addresses to host names. So what we're going to do is, I'm literally typing this in as I look at it on a different terminal, but we're going to take the general idea of what the line looked like and then adapt it for planets.lan. If you were looking at this in an SSH session, which you probably should be by this point, instead of like me looking directly at the console, you could copy and paste this in from a different window. Instead, I'm typing it out the slow way so that it painfully demonstrates to you the exact syntax of the file. The only thing that we notice here that's really important is that planets.lan is the name of the zone or the domain name that we want to create. This is a master server, which means it's going to hold the basic data, and that's the file that we're going to store the data in. Once again, I'm cheating. I'm actually copying from a second monitor when in fact it looks like I know how to type this from memory. I probably do if I were pressed, but for the most part I'm doing this line by line instead of copying and pasting so that you can see the format of the file, which is actually very important. Bind is incredibly picky about the format of the file. So as we go through here, I've added comments onto the screen where I thought it necessary, and I'll try to explain things as concisely as possible. This SOA record, Start of Authority record, is one of those things about the file format for bind being picky. It's supposed to store information about the owner of the domain, but in reality no one really uses it for that. The next line underneath of that, I'm putting in what's called the zone serial number, which is probably the most important part of the entire file. The serial number is probably more precisely described as a sequential number. Each edit of the file is supposed to increment the serial number by 1. This is so that when slave servers pull the record from this DNS, it has a version number. So when you think of the serial number, just automatically think of version number instead of serial number. The rest of the entries that are going in here are different TTLs. They control how often slaves can pull information, how long certain entries live for, things like that. For the most part, set them to something like 5 minutes, maybe 10 minutes. If you're out on the public internet and configuring DNS, you'll want it to be higher. What it does with higher numbers is it tends to reduce your DNS traffic because it lets servers on the internet cache your data longer. It's generally good, not always. If you need to do a quick swap of a domain name or something like that, one trick is to set the TTL really low for about 3 or 4 days, do the swap, and then raise the TTL back up afterwards. You'll notice here that a lot of this information is about primary, secondary, or master-slave configurations. It wasn't always that way, and if you see old zone files, the numbers might mean completely different things, but in bind 9, those are the correct definitions. And now that we're past the mandatory parts, we can go ahead and start adding actual zone entries. These are the entries that are going to map a hostname lookup to an IP address. The first to have is a record for the name server, or NS. This is indicating that the primary name server for planets.lan is server01.planets.lan, which is the machine we're working on. IN specifies it's an internet record, and NS is for name server. And I want you to draw special attention to the trailing period at the end of server01.planets.lan. That is absolutely required if you're using the full domain name. If you're not, you could just say server01 and the domain name would be appended at the end, much like I just did there. Next up, I'm throwing in an A record, or address record, which is what DNS servers of all types use to define a hostname to IP address matching. In this case, I have said that server01, which will have .planets.lan appended to it, is assigned to 11.235. At the same time, I want to create a different type of record called a CNAME, which is effectively just a reference. So what I'm saying is, if you look up jupiter.planets.lan, return a reference saying that that's actually server01. And then these two records kind of form the basis for my first version of the planets.lan domain. Once I save the file out, and I'm using Vi, so it's slightly different than from Nano, but once I save the file out, we can go ahead and restart bind. It's going to reread the file, and then hopefully, if the file configuration is correct, planets.lan will be available for querying. In order to do that, we have to have something looking to this server for DNS, and I'm going to go ahead and make the server look to itself. In order to do that, I want to edit etc.resolve.conf without the E, and I'm changing it from my previous DHCP-based configuration that's related to my local LAN at home to the new one that's specific just to the planet's network. Since I've configured it to look to itself for DNS, by looking up jupiter.planets.lan, we see two awesome things have happened. First, jupiter.planets.lan is an alias for server01. That's our CNAME record in action. And then server01.planets.lan has address 11.235, which is our A record in action. I can do a host lookup and I can ping it, so we verified now that bind is working correctly. However, for our DNS to be fully functional, we want to be able to look up 192.168.11.235 and have it do something. That's called a reverse lookup, and that means we have to set up a slightly different domain that's a little bit weirder in syntax. So once again, I'm going to go ahead and steal from the existing configuration. And if we look in default zones again, there's the slightly different version. Above it was zone 127, and now I'm showing zone 255. What we want to do is take this zone 255, which is a specific type of zone lookup that does reverse IP, which means it maps an IP address to a domain name and not the other way around. And I'm using again, particular syntax which was long ago designed actually before the internet was popular. If you're familiar with the ARPANET, this may look interesting to you. Using the .inadir.arpa is actually a special signifier to bind, but it's only special in that it deals with it in a different way. There's nothing special in the way that you need to treat it. Just take the subnet that you want to do reverse DNS for, flip it around backwards, and then add .inaddress.arpa to the end. Once you've done that, the actual format of the file is almost identical. So in fact, we're going to steal the file that we just did and change a couple of things around. When a request comes in to bind, the actual zone that's called is based on the configuration file that we just edited. There's nothing particular in the zone files themselves that match them to a particular zone. So I can take all of the initial header, copy it over, and then just change the entries around to match whatever it is that I'm working on. In this case, as I mentioned, have specifically put in an incorrect entry so that you can see what an incorrect entry looks like on a reverse lookup, because it's a little confusing the first time you see it. The first error message that we're going to get is the error message that you would get have you added a configuration but not restarted bind. The second error that we're going to get is when you have a valid zone file but you don't have an entry. In this case, the entry is incorrect completely. So what we need to do is try to debug why we're not seeing the PTR record. Even though we just set this up and it looks like that host should have resolved, it didn't. The reason is because of the way bind does host appending. Instead of using the entire IP address there, it appends the first column onto the name of the zone. So we were actually creating a much longer host name. A 192.168.235, 192.168.235. We actually outsmarted ourselves. Another warning, do as I say, not as I do. Always update the serial number. Just to get a little bit more repetition in, I want to go ahead and add a couple of more hosts. First off, I'm going to add an entry for Sol, which is what I've nicknamed my router for right now, which is 192.168.11.1. And of course, as every good bind administrator knows, I'm going to increment the serial number, just in case I have a secondary at some point that I want to be able to pull this zone. It's also pretty instructive to have another reverse DNS entry. So I'm going to put in the same thing for my router. This way it'll work both ways. And then, oops, forgetful me, I forgot to restart bind again, so the name lookup failed. Once I do restart bind, it should work just fine. I also want to check and make sure that my reverse entry works. You see that it's got a domain name pointer, the same as a PTR record, so we're good with the reverse DNS on that now. I'll spare you the pain of my narration while I do one more set of edits. I will note that here in a second I'm going to do the short form lookup, which is part of etceteraresolve.conf. It lets you look up based on just the host name and automatically appends the correct domain. What have we gained by this? Well, probably the biggest gain is that now you can set up your own virtual hosts for Apache. So once you have planets.land lit up and you have employees.planets.land lit up as a timekeeping record, you can add that in without having to deal with a third-party DNS provider. And then you can go ahead and add in intranet.planets.land and timewaste.planets.land, whatever you feel like. It's all free and you can do it on the fly, and then you can configure your Apache to work with those as well. As we move from DNS into DHCP, I think I need to explain the protocol a little bit. Somewhere on a network, a LAN segment, a DHCP server is running, and when a client boots up, it sends out a broadcast request to the LAN segment asking for an IP address, a net mask, and a default gateway. Also, it can get DNS servers and other miscellaneous info. The DHCP server sees the request and responds back with basically a permission slip saying you can use this IP address if you want to. What we want to do is move the DHCP service from the router, where it probably is now on your network, into this Linux machine. Eventually, you're going to want to know the finer details of how DHCP works, but for now, this basic overview is probably good enough. But I do want to warn you, if you have two DHCP servers on the same subnet, they don't necessarily know about each other. They can double assign IP addresses. They could be assigning IP addresses from two different subnets, setting up two different routers. There's a lot of stuff here that can go wrong, and this is the first thing that we're going to install on the server that could break other things in your office. So just as a cautionary tale, be careful what you do with the DHCP server. Having said that, there's really quite no test like testing in production. So let's go ahead and do an apt-get install DHCP3-server, which is the default server package. Also, I'm kidding, never test in production. The first thing you'll probably notice here is that the DHCP server failed to start. This is by design. It's specifically for the reason that if you bring up a rogue DHCP server on someone else's LAN, you will destroy it. What we want to do is to find out why it failed, and to do that we want to investigate the logs. So the first and most obvious thing is that it says there's no subnet declaration for ETH0, and in fact there is not. We haven't configured DHCP in any way, and so it fails because it doesn't know if the default configuration would be safe. To fix that, you have to configure DHCPD to understand what to do for every network interface that's in the server. There's only one on this one, and so we only have to configure it for one, but if you had 4 or 5, you would have to configure each of them individually. If we go into etc DHCP3 and check out the configuration file, we're just going to go down through it really quickly so that we can get it up and off the ground. Now that I've scrolled through most of the config file and haven't touched a thing, we can go ahead and declare our first subnet. We're already using 192.168.11 everywhere else, so that's probably what we want our DHCP subnet to be. If you look down through the file, you'll find an example subnet like the one I've picked out here. I'm going to duplicate the basic configuration directives to get it working. Hopefully you know your net mask and everything. If you don't, go ahead and check out the other machines that are already on your network. It's probably 255.255.255.0. The range directive here is telling the DHCP server what ranges it can assign IP addresses to clients that request them. I'm doing a very narrow range so that I kind of know which ones I'm going to get later on in the video. On your configuration, you'll probably want at least 20, maybe 50 to deal with your friends that stop by with their iPhones and things like that. The option domain name servers directive will tell clients what DNS servers they should be able to contact immediately after booting, and will end up being part of the network config once it's all booted up. In this case, I'm feeding it server 01, the machine that we're working on, because we just set up bind conveniently enough. I'm also giving it my default router, which is a piece of network equipment on my network, and setting up the domain name to planets.lan so that the short form will actually be able to look up. Now, even though we have this configured, it's still not going to work. What we have to do is go look for a line that says authoritative. It's going to be commented out because the authoritative line is what makes the DHCP server effective on the network. That is to say, once authoritative is turned on, it will actually start assigning IP addresses. This is really important, because this is the part that does the network destruction if you have it wrong. Make sure your config looks really solid, or make sure you're on a network that you don't care about before you uncomment authoritative and turn DHCP on. A simple services restart after saving this configuration file will get DHCP up and running. In the future, you can pretty much restart the DHCP daemon whenever you want to. Client leases are written to a temporary file, so if you restart the DHCP server and then every PC on the LAN suddenly requests an IP address, they'll still get the old one that they had before unless something has changed or you botched the configuration file. Now we have to test this thing. I've gone ahead and disabled the DHCP server on my built-in router, so I'm going to go onto a Windows 7 virtual machine and check out the IP configuration. You can see that it's assigned to 11.43, which is from my old DHCP range before I turned the server on and turned the router off. I want to use ipconfig/release. That's going to force it to drop all IP addresses on interfaces that it can do so. After that's done, I'm going to use ipconfig/renew, and that's going to send a specific request out to the network to get a new DHCP address. The server that we've got up and running should be the one that takes over from this point on. The DHCP renew request might take longer than you would expect. The first thing that it's going to try to do is reclaim its old IP address. Since my router is turned off, that's not going to be the case, but it has to hit a couple of timeouts before the new DHCP server will kick in. So we've got our IP. That's great. The problem is we want DNS and DHCP to match. I want the ability to boot up a machine called Neptune and have it update the DNS server so that anyone on the LAN can do ping Neptune and have it actually resolve to the DHCP address that was just assigned. It's entirely possible, but we have to make things more complicated. And, as I'm sure you've learned by now, I like things more complicated. This is more complicated because bind is fairly secure. And what we don't want is the ability for anyone to log into our network and randomly start adding DNS names. On a local LAN, again, it's not such a big deal. On the internet, it is a huge big deal. And so bind has a way of doing authenticated updates. And what we have to do is set up the authentication mechanism so that the DHCP server can authenticate with bind and update the zone files on the fly. Luckily, bind has given us a utility that does just that. If you look in etc bind rndc.key, you see a specially formatted file with a secret. Don't think of it as an encryption key, it's more like an authentication key. But you can generate your own using rndc-confgen, which is a utility that ships with bind. Feel free to just steal my command line directly. Otherwise, you can go through --help, check out what everything does. But really, for right now, we just need to generate a basic key. This is the new DHCPD key. So the next thing that we have to do is configure bind to use it. Now, you can probably search around on the internet for a pretty long time about how this actually works. But using the include directive, you can pull in a file directly, which means we don't have to have the key stored anywhere else. It's going to load it in as if it were a configuration file. Next up, we have to change around where some of the configuration files live. We have to do this because bind by default can't write to its own configuration directory. That's actually a security issue. You wouldn't want bind to get broken into and be able to overwrite its own static domains and configuration files. Instead, I've decided to throw the zone files into var cache bind, which is the location that's designed for this. And then we can also do allow update and feed it the DHCPD key, which is the name of the key that we generated before, so that any updates that are sent using this particular key will be accepted, but without a key or using a different key, they're going to be rejected outright. And since DHCP can update both the primary lookup and the reverse lookup, we want to make sure that both zones have that capability. The side effect of this configuration is that if bind restarted right now, it wouldn't be able to find the zone files that it needs. So we have to move them to the location that we told them it was going to be at. And remember that part about services having to run as a user? In this case, bind runs as the bind user. And we have to make sure that the bind user can read the DHCP key and that it can write to those two zone files that we just created. Since it's owned by root, it's not going to be able to, so we have to go ahead and fix that now. Otherwise, again, when we go to restart bind, it's going to fail. Finally, as embarrassing as it may be, I do make mistakes, and mistakes are instructive. Bind is going to fail to restart because I botched up the configuration file. And the log is going to tell me exactly where. It looks like I missed a semicolon on line 13. So let's go ahead and edit the file again and we'll fix it. When you use the VI or VI editor, you can give a colon and then a number and it will go directly to that line, which is really useful. And here you can see that I, quite unfortunately, left both keys without their corresponding semicolons. Bind should now restart correctly, and we can go ahead and set up DHCP. Here's one more tiny bit of behind-the-scenes magic that I've got to show you. We know that the DHCP server is going to have to read the DHCPD.key, but judging from these permissions right here, unless the DHCP server is running as bind, it's not going to have access to the file. So what we need to do is make sure that it can actually get to it. These two commands are going to set it up so that it can work with it. And now one more layer of complication. This one is called AppArmor, and AppArmor is a way to protect files from being changed or accessed at the operating system level. I'm not going to go into AppArmor. It's a fascinating topic, but for the most part, I'm just going to make sure that it works for dynamically updating DHCP. The main thing that we have to do is change one of the AppArmor profiles to allow the DHCP server to access the dynamic DHCP key that we added into bind earlier. All I'm doing is adding in that particular permission, and you can ignore the rest about AppArmor for now, although if you want to study it independently, it's always encouraged. Finally, with all of that junk out of the way, we can finally get into the actual meat of this, which is configuring the DHCP server to send updates to bind. What we want to go into is get into the DHCP config file, find the DDNS update style, and update it to say interim. This is a specific, and it has to be interim. There's some historical reasons why this is the case. For the most part, don't worry about it. We're also going to use an include line to pull in the DHCPD key. We're lucky in that DHCPD understands the bind file configuration format. Now, go to the subnet that we defined earlier, and we want to apply the DDNS key to it. We specifically have to apply it both to the domain name that we're looking to get updated and to the reverse DNS if we want them to both get updated. This is fairly straightforward, but basically you just create a zone entry for both of the zones and then set the primary DNS, which is the DNS server that actually gets the updates whenever DHCPD assigns an IP address to a new client. And yes, I know I'm throwing a lot at you all at once, and I'm sorry, but I think that you can handle it. And if you can't, just go back to the beginning of this and put it on mute so that I shut up, and run through this 1 or 2 more times. The text and the highlighting is fairly instructive. I'm trying to be conversational about it. But all of this stuff can be done with the examples that I've used. Once again, I forgot that pesky trailing period. You'll do that many times. Don't worry about it. Restart AppArmor, restart DHCPD, and we're ready to test to see if our dynamic DNS updates are working from the local LAN. To do that, I created a new virtual machine called Mercury, which I'm going to force to get a new DHCP address while I tail the logs on our DHCP server. So I'm going to invoke a special version of tail called tail-f that opens the file and continuously dumps new input. So what I've done here is tail-f varlog messages in a different window on the VM. I have requested that Mercury get a new IP address. You can see that we've got an added new forward map for Mercury. We've added reverse map for Mercury, or from 11.100. DHCP request went through. Everything seems to have worked out okay. So we need to do the DNS check and make sure that it resolves correctly. And it does, which is really cool. So if we check out varcache bind, we'll see that there are now 2 new files in there, .jnl files. They're journals, and when dynamic updates come into bind, they're actually saved to these journal files, and they don't affect your zone files until you freeze them or restart bind, at which point they're saved out. I'm just going to spend a little time here looking around the config file so you can see how they've changed. I think I finally reached the end of this screencast segment. I know I covered a lot. Go back and rewatch it if you need to. Definitely experiment with bind. DNS is one of the services that you should know inside and out. DHCP to a lesser degree, a lot of times is taken care of by routers, and that's probably not such a big deal. A lot of corporate environments are using something like Active Directory that does DHCP and DNS at the same time, and all this is taken care of for you. But if you have just a local network and you're looking to do kind of a neat feature so that you can name your laptop and always SSH to it, which is exactly what I do at home, this is the perfect way to do it.